Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, connected to a network cable for VNC, serial cable for RS232 data acquisition, connected probes for getting the serial data on an oscilloscope, and a RaspberryPi on a fischertechnik stand. RaspberryPi gives a bit delayed live stream on this breadboard with some electronics, and of course then connected via a band cable. A part of this experiment is centered around this MCP3008, which is an analog to digital converter. Light dependent resistor 1, light dependent resistor 2, and this gives resistance, which are analog values, so they have to be converted into digital before going to the Raspberry Pi. Also an NTC negative temperature coefficient resistor and other resistors. Also an Android tablet with a Pi scope, which I have now only working on this one. So this is a VNC environment, and two others on a Linux computer and on a Mac. And with this one I can see signals which are coming from or actually on the Raspberry Pi. So on that side of the signals, and the oscilloscope gives it actually on the other side, and if they are the same, I'm happy. So the purpose is to write do an experiment with Python, serial data acquisition, and then see if I can store things and if I can actually separate data. So can I separate a light dependent resistor 1 from 2 as a matter of data? So let's see how that works out. Right, so this is another view. VNC on the Linux laptop running Fedora Linux, which is actually the development version of Red Hat. What do I have here? Well, first of all, a webcam which I have connected to the computer, and this is the circuit that I am dealing with actually this converter. Then Android tablet. I was trying to get this image from the RaspberryPi also on a tablet, but that didn't want to receive or play the stream. And now that I do not have my lighting on the circuit, I can actually see here what is happening. Then datalog from last time, minicom from whatever, displaying everything over the serial cable. So whenever I go to Octave to play or to put the serial data anywhere else, I have to quit minicom, otherwise it will be garbled data. Python code and oscilloscope set to serial mode. Now the question is also, let me put it like this. If I run these are all commands that I used. Okay, if I run this, does it actually show what is going on? It should do, and yes, it does. Not quite sure if you can see it. And here you can see all data going on. And with the bare eye it is better to see, but well, what you get with 20 frames per second is nice. So now that I am going to the data log, do I see exactly the same? I don't think so, because now the data log is being, if you, yeah, I did just a let with the command used to look into the data log, and now it will be, oh, it's already been filled, that's good, but it has different data. So if I put my finger on top of this LDR, what will happen then? And then the data will end. No. Okay. LDR value is 31. I remove my finger. It will increase, I think. It is not increasing as much as I had thought it would. Anyway, one of the things is that this program is reading everything. And you can see by doing more stuff on an old board as Raspberry Pi than Raspberry Pi 1 B plus, to be exact, things slow down a bit. Let's see, for Octave, for Minicom, everything is being printed. Still the register value is 0, which I find rather odd. Right, let's keep it this way. Anyway, time for Octave and see if I can get things out of the array which I have made here. String compare if things are equal to LDR, light dependent resistor, then they're equal, otherwise they're different, others. And what I want is to get the actual data, and that's going to be a tough one, because when is it? How many spaces do I have to use then? And that's what I'm going to do now. So LDR1 is the target for now, and LDR1 is with value, and I did it last time again, or also, I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 spaces. 14 positions after LDR. So let me quit the program. It's 14 positions after. And I have here 3 positions. So actually I need to print what is 14 positions further. But how do I compare? You can't compare a string then. and that's a bit hard. Let me say I have here 3, first 3 then, and then 14 positions, and then 3 plus 14 is 17, and I'm here going to 16, and LDR 1, if I look here, is 3 positions, which means that I have to extend these two. So I'm talking about LDR plus 14 positions makes 17 plus 3 from the value is a value, and then value is 17 plus 3 in total. So I need to extend this, and I will have to do it here for another 3 positions, 4 positions actually. So this will be 20. No, I have to extend it to 20. This will be it. Then this will be zeros 20. They have to be equally as long. So this will be and so will this be. And I hope I'm counting correctly, otherwise it's going to be a problem. So this is one thing, and now I have to print data 2 positions 18, 19 and 20, I think. So let's make that data 3 is that's a nice one. How to fill that in? Let's just take everything of it. And transpose. And then display it. Oh, then this transpose will not be necessary, but this one will. And flush out. Otherwise I don't see anything. So with a bit of luck and reasoning, I now get all the actual data in it. But will I? Let's just say minicom end. and go here. Press F5 to start. Oh, that's not going to work then. Oh, right. I just have to say disp. Oh, that's a good one. Disp data3. And then data3 transpose. Again. It seems that it works now, or should be working. No, because I'm not running the program yet. Now I'm running the program, and where's Octave? Here. Non-conformant arguments. Line 22. Really? Oh, right, of course. I'm reading only 60. I have to read 20. So, save and go. And now things work. Oh, and then another thing, of course, it's only useful to print it when it is equal. Only print it when it is equal. So if this is correct, then do this. And now it should really work. Let's see. Run. And I say, oh, not here. Here, run. Pressing F5. And then I need to go here. Datalog, what is being printed, if something is being printed anyway. Is gelijk or anders being written to the datalog, because I see here anders, and that is okay. Let's see. And oh, it's only being printed. Here I do not have a datalog into for Octave yet. So that will only be on screen here. Let's see if that already happened. Am I looking at gelijk? I don't see it here. Yes, here. This is gelijk. Data 3, answer is 25. Is that correct? I'm not quite sure. Taking these characters, and that will be 25. So I missed 2 other characters. Really? Oh, here I have it as well. And then it is 257. Oh, that is nice. Here it says LDR value is 247, and here it says 247. So it does print it, and that is nice. Yes, it looks like it is working. And do I have it somewhere else as well in the meantime? Not yet. Okay. Let's go further. Oh, and here, yes. So here I have it the same, 245, 245. 254, of course. So I can see it by the spaces. So that's nice to know. And otherwise it's just different. So if I now put my finger on the LDR, I should see something happen with a different value. And there it comes, 255. That's not the answer I was looking for. And there it is, 190, 109. So actually this way it does work. That is nice. So with indexing, in other words, not using, yeah, I am using the actual elements in the data, in the vector, to determine to select the value. And this way I can single out every value of LDR 1, 2 and 3. That is nice. Now it would be also nice if I write it to another datalog instead of this one, because this one is written by Python. And by fwrite, but from Octave I can in C script, C language, write it as well. So let's go there. So I have added the file name including fprintf for data, and since I want to know which is which, I have put S1 here and data3 being the value behind it. Question is, does it work? Well, yes, it did work, but considering this and this, how does it end up on the system? Not on the RPI. So now I take the minicom window and I am looking for the file name, which is this one. Ooh, 0, nothing in it. There is absolutely nothing in it. Oh, and I made the mistake, this should be an 8. But it's absolutely 0. I did not expect that one. So, how come? Now I have to remove this file and start over. because why is it empty? I'm going to run it a few times, or once, but okay, Anders. It started with gelijk, and that is supposed to be. And no, the other one. And I realize it is very difficult to watch, but here are actually the signals. TX and RXD, which mean transmit and receive. It's really difficult to see. Even though it is better without light, even hard. But this is SPI on top here, and here are a few things transmit. And you can see that also here. Now, how many occasions of equal do I have? Not much. Not much at all, actually. Let me go to this window and see if I actually do have some data. No, I have no data at all. That is surprising. Why do I have no data at all? Because nothing is written? I don't believe that. So I quit and I start scrolling back to gelijk, which is right here. This should be written, or am I doing it wrong? Okay, I will split this up. Maybe that is better. So this is then one thing, and then, although I did not get any error message, and right to there, and then once again, oh, this will be D. Yes, absolutely D, because that is value. And then data. And after that, maybe new line. But we'll see. Let's do it again. And soon I have to end this video, but this is one thing. It should already have been written by now. But how much is it? And by now it is, of course, an 8. Still 0. Oh, that's not good. Do I have gelijk instead apart from the first one? I do have. A few. So it stays 0. There's nothing coming in it. Ooh, that's not nice. That means that I'm doing something wrong. Question is. Right, last piece before wrapping up. I wanted to show the difference between pi scope and the oscilloscope, but the unfortunate thing is that there's a freeze and a big lag. So if I now start this again, what do I see? Do I see exactly the same? Unfortunately not. Here I see nice signals going on. This is a serial peripheral interface, and this is a transmitted signal. But if I'm looking here, it seems like frozen. So, although I see now, right now nothing, and now it was almost the same. So I'm afraid I have to stop and start this view. And yet again, this really doesn't work out. Whether that is due to the lack of speed on the Mac or anything else, I can't really say. If I compare this to what I see on the other laptop, then there is lag as well to some extent, but much less. So I think this idea of putting two cameras together, that is not working out, unfortunately. Oh, it can also be the age of this camera that I'm using. But mostly lack of the computer. Anyway, it was a nice idea to show. And yes, PiScope may also be lagging because it is now it is running on a very busy Raspberry Pi. But I think alright, so that really is the end of this video. Something worked out, some other did not. So keep trying to get things working the way I like. For now, thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, much appreciated. You can also follow me via Instagram and Twitter. Please show support by making a donation via either PayPal or Wired, and you can also become a patron. You may have your name mentioned depending on the pledge you make. Much more information on my website and also on my Patreon page. All information is under this video, including the URL to my website. For now, well, to be continued. Have a nice day and bye bye.